concepts used while writing the pseudo code. It's not a gap. Oh, still there. Okay, no problem. So it's not a gap. It's
We are live only. You go ahead.
okay. Yeah, thanks.
Thank you.
Yeah, okay, thank you so much. Okay, so it's not a gap. It's actually that is how theory and practice works. So theory is something. It's a very dried one, and well, only we can explain the concept and how to do. But when you do it, you will realize it. I mean, so once you PD code. There is. It's not a PD session, man. I mean, this is just a discussion session. I will not ask you to post any answer over peer deck or Menti. It's not a PT session. Okay, so shall we start? I mean, we will discuss question by question. So that will be the better one. So let me. Yeah, yeah. All the sessions are recorded. I hope there is a YouTube link for everything. So yeah, for the YouTube link, just check the portal. They will update the YouTube links. Yeah, we can start. Just a minute. I will open all the necessary things. Okay. Okay. How many of you find the first question is easy? Yeah, we can start. I'm starting from the first one. Okay, so moderate. So the first one is based on recursion. Yeah, it's easy. Okay. Divide can be divide with 0. Yeah, last we will come question by question. Selin Saji. Okay, yeah, we will. I will come to your question at the end. Okay. Yeah. So the first question, it's based on recursion. So there is a procedure calculate. Okay. So let me write few things about the procedure calculate. Okay. Question one discussion. Okay. Okay. Yeah, I'm unable to share multiple screens. Otherwise, my full screen is visible. So I'm using external monitor. It will be very narrow for you if I share the screen. So better I will share the workout solution, and you can open the question on your side. Either you can open the PDF or the portal, so that you can see this question, and I also work out on this uh, writing pad. Okay, I'm sorry for that. Unable to share the question now, but anyway, I am opening the question in my side and I am seeing this. Okay, so the calculate, it receives two parameter, a list L and assign. Okay, what is your first observation about this procedure? What is L? It's a list. Yes. So L is a list. Then what is sign? Flag. Boolean value. Yeah, it's a Boolean. Okay. Yeah, it's and also it's a list of integers. It is important. Okay. So now we want to decide what this procedure calculate do. That the, I mean, first we have to analyze. So, what are the two steps we have to taken care while processing this recursive procedures? We have to find two steps in while solving this recursive pseudocodes. Ending, okay. End condition, yeah, yes. Base condition and a recursive step. These two are the important things. So the first one is, what is the base condition? Okay. The second one is, like, sorry, it's pathetic. Recursive step. Okay. So here, what is the base condition? Yeah, the base case, when I just write it literally instead of writing the word, when L contains exactly one element. Yes, it's correct. When length of L is equal to 1. Hey, regarding the YouTube link, I hope it will enable at some time. I mean, that you can see even later also. Okay. So if the YouTube link is not enabled, it's not an issue. Just listen over here and at some point of time they will enable. Yeah. Okay, it's fine. So it's YouTube link is there on the portal. Please click there. Okay, so the base condition when L contains exactly one element. Okay. So what is the recursive step then? Yeah, identify the recursive step. What I mean, how the problem is made into a subproblem and invoke the same process to calculate. First of, last of L, return statement. Yeah, so we have to identify what is the use of the variable sign that actually decides some operation. Okay, so let me write it as a, maybe the pictorial representation will be more helpful. So let me write that flowchart kind of explanation for this. Okay, so this is where we start the procedure. We have a start. Okay, and assume this start receives two parameter. One is L and another one is sign. Okay, and the next step is, it's a decision. The decision is actually checking length of L equal to 1. This is true side and this is false side. Yeah, if it is true, return first of L. Yeah, then we terminate. Okay, so now we come to the false side. That is actually the recursive step. Here I can say uh, this part is actually base case and the other part, whatever we are going to see, is actually the recursive step. Okay, so what is the first step of the recursion? So we want to find x value. X value is initially set to 0, but it is decided based on the sign. Okay, so the first decision is on sign. This is one side and this another side. Let's say this is true and this side is false. If it is true, then what we are doing, and false. Okay, so if it is true, then we have to add the first and first of first. Okay, so this is little crucial. I hope most of you have encountered this. Let me write. So if I have a list that contains, sorry, x1, x2 and so on to some xl for smaller elements. Okay, what is first of all? Yeah, nice. X1. Okay, and what is first of rest of n? X2. Yeah. Okay. So then what is first of L plus and first of rest of L? It is sum of first two numbers. Okay, Karthik Das, it is not x2 dot dot dot. I mean, it's not all elements from x2. It's actually x2 only. Yeah. Okay. Yeah, it's x. So we say x is equal to x1 plus x2. Assume this x1, x2 are the first two elements of L. No, we are not adding pairwise. No, this is true only when the sign is true. But I mean, if you look at question number 2, that is question number 3 for you, I think. So, what is the written value of calculate of a particular list? There we pass the parameter false. It's not true. So, in false case, you have to do x is equal to x1 minus x2. Yeah, that is correct. When false, we have to invoke the minus. And after doing this, we have to come to the common step. Okay, there we again call the procedure calculate of whatever value we computed x plus the remaining thing. Actually, the remaining thing actually, we have L as input, and the parameter that we pass is actually x plus what is that? Rest of L. Rest of L. Actually, the first thing is you should process it. What is rest of L? Let us assume x1 to xl is the your list. Then what is rest of L? No. It's I'm not asking only rest of L. Yeah. So it's actually the list contain x2 to xl. Yeah. So then what is rest of this? Rest of the list then contain x1 to xl. This is actually x3 to xl. Okay, then my final list is actually x plus plus x3 to xl. Then my list become x comma x3 comma up to xl. Yes, correct. So this is same as x1 minus x2 comma x3 dot 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 to xl, right? Is it clear? I mean, we are calling another, I mean, the same procedure calculate with the parameter x1 minus x2 as the first element, followed by x3 to xl. Yeah, if someone is unclear, please Okay, so notifications on. Okay, how to turn it off? Let me check. Wait. Okay, for the not clear case, I will. Yeah, I will. I will explain it again. 1 minute. Oh. Hey, can anyone find me how to disable this link? I mean, the notification sound. I don't know how to do it. Okay, IIT Madras host, are you there? Hello? Okay, I think person is not available. Yeah, I cannot find any option to do that. Okay, menu bar. No, I'm not getting any menu bar over here. Okay. Yeah, okay. Okay, fine. So, yeah, even I don't know how to do that, but anyways, some beep sound we have to digest at this point. Okay. Okay, so that if the sign is false, then we are making this list. What happens if the sign is true? Okay, there is entry and exit on. Okay, fine. I disabled it. Okay. So is the answer 17? We will come to the answer later. Yeah, thanks. Okay. Okay, so, suppose if the sign is false, then we do x1 minus x2 as the first element, and okay, Sabash. So then x3 to xl. Okay, what happen if the sign is true? What will be the parameter that pass to the list? I mean, pass to the procedure calculate in the recursive call. Okay, yes. So x1 plus x2 appended with the remaining elements. Okay, so here I'm making the call calculate of, let's say, L prime comma S prime. That is the new parameters that we are going to pass for the calculate. So L prime is actually x1 to xn if sign equal to false, and L prime is equal to x1 plus x2 comma x3 to xl if sign equal to true. Okay, so this is our modified list, new list, and that is parameter for the recursive call. Okay, so then what is the sign? The if I pass sign as a false, then not of sign become true. If I pass sign as true, then not of sign become false. Okay, if you look at the recursive call, you can draw this something called the recursion tree. I will draw it now. You can extend it for other cases. For example, if I do calculate of x1 comma x2 up to xl with a sign, then next time I use calculate of x1, so I just use some special operator, that is dot. Let us say, let me explain what is that. X2 comma x3 comma dot 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 to xl with not of the sign as the parameter. Okay, and this again calls calculate with the first one is x1 dot with x2, another operator with x3 comma x4 up to xl as the list with again sign, because not of sign become sign. Okay, and this will keep on go. Finally we obtain calculate of a single element x only will be there and a sign is passed. Let me use sign prime. Yeah, I mean the general thing you can see so that it will help for the other things instead of taking one such example. Okay, so we will output x value. Yeah, you can assume it's a sign prime because it's, you don't know whether the final one is the true or false. It depends on the number of elements. So you will output x. So then you will output this value of x to, now the this is assigned to this value x, and now you will output this x to the recursive step. Then finally, then this is actually now assigned to this x, now this is returned, and the final call of x is stored here. Okay, so then you can interpret this as the whole list x1 x2 x3 x4 up to xl, and the first calling sign is actually, if false, then you do first time minus, then again you pass not of sign, then it become plus, minus, plus, and so on. The final thing is depends on the number of variable, it may be either plus or minus. Suppose if you pass your sign as true, then first you do the plus operation, then minus operation, then plus, and so on till xl. Okay, so now based on this is actually the whole function of this calculate. Either it compute based on the sign. If the sign is false, then it computes x1 minus x2 plus x3 and so on. If it is the sign is true, then we compute x1 plus x2 minus x3 and so on. Okay, so then now we come to the actual questions. So the first question, actually q1, in my it is actually subpart. Okay, so in the portal it may be the question 1. Okay, so is there a side effect? What is the answer? False, no side effect. Yes, so nowhere, if you look at the code, nowhere we assign the value for L. Okay, so because in some place you can see first of L and first of L. Okay, but nowhere we change the value of L. You can see even in the explanation of the code, here we take the rest of L and first of L all the values, but nowhere we assign that is the new modified L. We say that it is a different L. I mean, we create a new list L prime. Okay, so we are passing a new L to each call, right? It's not a new L, it's actually a new parameter. It is not I mean, we are modifying the existing L. L is the some new parameter that used in the new recursion step. See, so when you invoke this calculate with the parameter L, when you go to the next level, it is once again a new parameter. Let's say this is your L. Okay, and this L is for the calculate of the first execution of the calculate. When you come to another execution of the procedure, I mean, once again you are calling the same procedure, but this L is different from this L. It is not meaning that I modified the L, so L has a side effect. So this is the basic understanding of procedure when you invoke recursion, because this L and this L are the different ones. If you make any change over this L, okay, then only you will encounter the side effect. Yes, obviously. So no elements in the list L has been changed. Suppose if I make L is equal to rest of L, then I remove the first element. Then it is a change. This change is applied to the list L. Then it is the problem. Now L is changed. Then the side effect may occur. But throughout this code, nowhere we changed the variable L. So then there is no side effect. Yeah, if list has two elements, then we do x1 plus x2 or x1 minus x2 and we return that value. Okay, so the modified list in the sense, okay, it's actually, we cannot say it's a modified list. We can say that it's a new list created. Yeah, suppose in case side effect is there. Okay, so consider the same procedure with the following modification. Let me call L is equal to rest of L. Okay, and I'm passing the for the procedure, instead of L prime, this is actually x plus L. Okay, then L is updated and this is actually side effect. The argument for there is no side effect is very simple. One word answer is actually, we did not change the role of or value of L at all. If you look at the code, nowhere we assign L is equal to something. If you assign something like L equal to 1, or if you change some value of L, then only the side effect will occur. In this recursion, nowhere we set L is equal to something. We only use L in many places. Okay, so I hope this is very convincing answer that the side effect is not occurred in this piece of pseudocode. because L is not changed. Okay. Shall we go to the next one? Okay, so I have seen one option for pole. Let me try that. Oh, polling is not allowed. Okay, I mean there is no possibility of poll. Okay, the answer is, I mean, false. There is no side effect. Yeah, so we go to the second question. Calculus returns an integer. I mean, I hope I don't want to spend too much time for this because you can see what are the return statements in the pseudocode. So in the base case, what we return the first of L. L is a list of integers, so first of L is a integer. Okay, and in every recursive step, we return the calculate. I mean that means we recursively call the same procedure, and whatever the base case return, it will return the same value. So it is once again integer. Okay, Aditya Kumar. Yeah, let me 1 minute. I will unmute you. Hey, yeah, Aditya, I request you to unmute.
Sir, I was saying that uh, from your point that L as if taking as the original input which was passed probably from main,
Hmm.
where L which was passed, yeah, there the question is a bit ambiguous. I think like
Why?
there are two L's. Like first L which we think like which can be V also, like first L which was passed from the main to the function, and the next L which is defined in the function definition which
No,
gets
no,
applied
nowhere.
in the
One
call.
minute. Nowhere we say the L is defined in the function definition. It is a parameter.
So like okay, then if it's defined in the function definition, then it will get changed always. Like
No, no,
then
no. Where it is changed? See, what is L? L is used only in one place. Procedure calculate L comma sign.
okay.
Okay. And inside the procedure, do we use any other variable L other than this parameter L?
No, like we
No.
don't use L, but like for the next iteration, our L will be
No,
different
no,
now.
no.
Like
You don't go to the iteration. Okay. We will go step by step and don't jump it. Okay. Others will get confusion because of that. Okay. So this L value is a parameter, right?
okay,
This parameter is changed anywhere. That is my question. Is it assigned a new value or modified?
throughout one call, it is not changed. But
No, no,
if
not only throughout one call. I'm just asking, is it changed in this execution?
yes, there is definitely it is
Where,
changed. Like
where, where, where it is changed? Can you tell me the line number of the
when
code where it is, you find that it is changed?
when when we pass calculate x plus rest L, okay, so automatically this when we are assigning it is equivalent to saying calculate L is equal to this
No, no,
value.
no, no. It's not L. Calculate L is equal to. It is actually calculate of x plus rest of L.
Yeah, but what is it is being passed to, it is being passed to L, like it is being
No.
assigned to L.
Is it a new method? It's actually calling a method. That method's parameter is assigned. Okay. Let me write that clearly. So you are using calculate. So you are okay. So you are making calculate of L comma S sign. Okay.
Okay.
And in after some piece of code, you are use calling the same procedure calculate of x plus
Rest of L. Yeah, comma there's something which we don't need. Okay, that just when we are discussing this portion only.
okay.
So
So you are making this computation, right?
yeah, yeah.
So assume your
But this
main code is somewhere
computation is
else.
being
1 minute, 1 minute, hold on. Let me
okay.
explain.
Sorry.
Yeah. So I'm calling in my main code. This is my main pseudo code.
Okay.
Calculate of some list x1, x2 up to xk. Okay, before that I will define my L. Let me instead of L, okay, let me call it as L. L is equal to x1, x2 up to xl. Okay, and here I am passing L comma false. Okay, so what is the meaning of side effect? Yeah, please talk. I mean, okay, so he's in mute. No, I can hear some sound. Aditya.
Yes, sir.
Okay, yeah, tell me what is the side effect? What is the meaning of
Yes.
side effect?
Side effect means like whether a given variable or
Is
values gets
modified or
changed,
not?
modified during an operation.
Okay, so now what does this calculate will return? What is the return value by this execution? You understand the code, right?
Yeah, yeah. It will
What it
return
will
in
return?
integer. Integer.
Yeah, x1 minus x2 plus x3. This exact value of this will be returned,
Yeah,
right?
yeah. Something
Okay.
like that.
If I print L, then what is the value of L?
Then it will still be the same.
If it is still be the same, then how it side effect happened?
Y- What I said was like the question is bit ambiguous.
No, it's
There
not
should be a
ambiguous.
clear,
That is what
what
I'm arguing.
there should be a clear distinction between which L is it be talking about, whether it is talking about the L mentioned in the main or it is talking about the L defined in the function definition, because L defined in the function definition will get changed on each call. That was all that I was saying.
No, one thing I want, I mean, maybe I will make one point and then leave this question to everyone. Whatever you are setting here as parameters L and S, suppose if I use somewhere else L and S, it not mean that this L and this L can be same and it's the variable names. This L is only for inside the definition of calculate. It can be used only inside the implementation of calculate. Okay, so then if I change this value, then it will affect the value which is called. It will not affect anywhere else. Okay. This this cause side effect when I say L equal to rest of L, then it means L is modified. Then the same modification will reflect here, and when you print L, then you will get only x2 to xl. Depends on the computation, but I just write for one execution. Okay, L equal to rest of L, then it will do only one. Okay, then since we are not updating, this is nowhere happened in the code. Okay, so that is why we claim that there is no side effect. Okay, so if you have further doubt, then you can write to the forum. We can move to the next question. The one thing that I mean, do not get confusion of the passing L to the recursive side steps. Okay, so second question is little straightforward. That it's true. It is returns an integer. Okay. Now we come to the third question. Okay, so Tatatreya Prabhu. Okay, actually, it will not print a return different L. Suppose if you print inside the recursion, it will print the different value. But side effect only we have to consider after execution of your some procedure. Yeah, so Tatatreya.
Yeah, Vijay, thank you.
Yeah.
I wanted to actually put this in the context of recursion. I mean, what you
Hmm.
explained is fine. Like within one loop, within one procedure call, it'll be fine. L will not change. I agree with that. But the
Okay.
interesting thing is we were taught about side effects even before recursion. So now, if you want to visualize in the context of recursion, and if
Hmm.
you do a print L anywhere inside the code, anywhere,
Okay.
I think it should not change, right? That should be the basic definition to detect whether there is side effect or not.
Yeah, that is also fine.
Then if you put print L somewhere in between, where these array is being passed in the name of a dummy L, okay, then L is like a dummy parameter. I agree that you are saying L is only a parameter, even if it is modified. But then if you do a print L anywhere inside the code, and if that is a good definition for detecting a side effect in the context of recursion also, then we are in trouble.
No, we are not in trouble because I will tell you why.
Okay.
Yeah.
You can mute me because I don't have anything else to add.
Oh, okay, fine. Yeah. I think once you mute, then it will, and the permission will go away. Yeah.
Okay. I'll mute it. Yeah.
Okay.
Go ahead,
Yeah,
Vijay.
I mean, yeah, okay, Prabhu. Yeah, I mean, his argument is very valid. Suppose if you want to check is there a side effect or not, just put after every line just a print L. Okay, and if all the printers are giving the same answer, that is what I mean. This is the difference, Prabhu. It's not I mean, you need not expect the same value in each recursive call. In each recursive call you will get a different, because you are passing a different parameter to the each recursive call. When for the first recursive call you will pass x1 to xl, in the second recursive call you will pass x2 to xl. But if you print that L in every place, I mean, after execution of a particular statement, you will get always the same printing statement. The value of L remains same in everywhere. Okay, so in that case, you can assume there is no side effect happened even with recursion. Okay, so with this definition, I mean, we can go to the next question. Okay, so this is actually execution type. So we have to find the value of 10, 12, 2, 8, 25. That list is passed as the parameter. Okay, so if we don't move on, we will have side effect for quiz 3. Okay, sorry. So I thought it's some meaningful question. Okay. Yeah, so the question 3 is, now it's straightforward because this will help you. Okay, so what is the parameter passed? 10. Instead of x1 we have 10, x2 12, and x3 2, 8, 25. Okay, and the first one is sign is false. If it is false, I have to use minus, plus, minus, plus, minus. Okay, you can evaluate. Suppose if you are not getting this, like sign equal to false, then what is happening? Okay, then you can go to the execution, you can execute in your own style. So let me show one execution from my side so that it will help you. Actually, question 3. So what is the list first? So I just calculate of the list is, oh, you want to use the fresh page? Let me put line. Okay, so calculate of 10 comma 12 2 8 20 5 and false. Okay, since it is false, x is equal to first of which is 10 minus 12 is equal to minus 2. Then I calculate of minus 2 comma 2, is it 2? Yes, 2 comma 8 comma 20 comma 5 with what is not of false. The next parameter I have to pass is true. Yes. Okay, so now execute this procedure with these parameters. Don't consider the previous execution, assume it is a fresh execution. Okay, So then x is equal to minus 2 plus 2, because note that the parameter is true. Okay, so then this actually 0. Then again compute, calculate of 0, 8, 25, comma, now yes, false. Okay, so the next time compute x is equal to 0 minus 8. This is because of this false, which is minus 8. Now again calculate minus 8 comma 20 comma 5. Now we have to pass true again. X is equal to minus 8 plus 20, because of the parameter true, the answer becomes 12. Then again calculate the list. Oh, sorry. Yeah, the list contains 12 comma 5 comma false. Okay, Yash, why parameter changes after every step? See, you have to follow the procedure, right? So look at the procedure pseudocode. So in every step after updating x, we are making a new list x appended with okay, if sign is false, then not of sign is not false. That is true. Yeah, that is true. We have to flip the signs every time. We have to flip from true to false every time. Yeah, that is correct. Okay. So for this, I compute x is equal to 12 minus 5, which is 7. And again, I have to calculate of 7 with true. Now I encounter the base condition, because the list 7 contains only 1. So if you say, if you want to write, let me write it as length of 7 is equal to 1. So return 7. Now this value is returned to this procedure. So this will get the value 7. This is now returned to its calling procedure. So this procedure will get the value 7. And this is now returned to its calling procedure. So this will get value 7, and so on. Finally, you get for, I mean, I don't want to write, okay, there are only one more step. Let me write both. We will get the same 7. So finally it returned to where it is called 7. So we can write that the calculate of 10, 12, 2, 8, 20, comma 5, comma false is equal to 7. Okay, so this is execution. I mean, suppose if someone asks how to see the question, I mean, how to solve the question, then this is the way to solve. So you have to execute it step by step and see what is the answer. Okay, so any doubt in this question? Okay, Chandrasekhar Reddy. Not 7. Is it 10? No, it's not 10. I mean, where you will get 10? No, you are incorrect. Because you said it is 10 because of the first element. We will return the first element only if the size of the list is 1, not every time. So the size of list become 1 only it has singleton element. That is only in this case. So in this case only we encounter the base case. Okay. Okay. So with this I will go to the next one. Maybe the detailed proof. I hope it is uploaded in the portal. Please check that. Okay. So now I am going to the next question, which is graph based. Okay. Okay. So we have to create the matrix, adjacency matrix M. Okay. Yeah. So I am going to the next question, which is the creating graph based on the student relation. Okay. So the first question, what does this graph related? So suppose if I have student I and I have student J, K, and so on. Okay. When will I have edge from I to J? This is the first question you have to ask yourself. Suppose if you are solving some graph based, how do you construct the graph is the important thing. Okay, when I scores more than J, okay, so there is an edge from I to J. It is a directed edge, note it. It is not undirected. Like IJ is like JI. IJ is different from JI because it is directed. If, what is that if condition? Can someone fill? No, it's not either way. It is actually directed. You can see when it is either way and when it is directed. I mean, undirected and directed means I greater than J. Is it I greater than J? I not equal to J. I scores more subject. No, no, no. Note that there is one for each subject in L, x dot subject greater than x dot y. Let me take mathematics. Okay, and physics. These are the three subjects we have. Chemistry. Okay, and I have I and J. Okay, and these are the marks. In chemistry, mathematics, I scored 70, 40, 55, 55, 60, 65. Okay, so now you tell me what are the edges I have to add between I and J. Ravi, I will come to your question. I mean, I will finish this question and I will come back. Okay, so first question. Okay, so let me pose the question properly. Is there edge from I to J? Yes. Okay. Is there edge from J to I? Okay. Yeah. So since you captured this logic, that is, since I score more subject in mathematics. Okay. So then the edge from I to J contains mathematics label. Okay. And J scores more marks in chemistry then J2I contains the label chemistry. Okay, so I hope most of you get the knowledge of the graph up to this point. I mean, this graph represents the student relation among them based on the score they scored. I mean, depends on the who scored the maximum than other. Okay, so this is actually the construction of the graph. There is an edge from I to J, then I scores more marks than J in at least one subject, and those subjects are listed as a label. Okay, so now we go to the first question. I mean, first question in the sense in this subpart. Okay, for a pair of students I and J, there is no edge between them. Then what is the okay? Then which of the following statement is true? Yeah, can someone tell me what is the statement? Yes, marks equally in all subject. Okay, so why? Can you say the some proof of correctness? Why it is? I don't know what is the question number. Please note yourself the question number. Question 4. Okay. Yeah. Okay. So since I and J are there, but strictly there is no edge in either direction. Okay. So suppose if I and J scored a different, this is, I mean, something called proof by contradiction. You can say that suppose if there exists a subject S such that let me use this IS, that is the score of I in subject S is not equal to JS. It means either IS more than JS or IS less than JS. Suppose if IS more than JS, then there will be an edge from I to J with a flag as a label S. Suppose if IS less than JS, then there is an edge from J to I with label S. Okay, and this is not possible because we started the claim that I and J do not have any edge between them. Okay, so this is true when in all subject I and J scored the same marks. Okay, is it convincing? Shall we go to the next one? Okay. Okay, so the next one is based on the procedure, recursive procedure find. Question 5. Okay, so now first we understand what is MIS, and M is the matrix that represented this graph, and I is the student and S is the subject. Assume I is the student. Let's say this is the vertex which is passed as a parameter. Okay, and what is the first I have to check? I'm iterating over all J, right? So okay, so this, there can be some vertex here, 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 and if there is an edge from these vertices to I, and that edge contains the label S, it may contain some other label also. Let's say S dot dot dot, means it may or may not contain S, but it can contain other subject also as label. Suppose if I find such a J, then I will call the procedure find of M comma J comma S. No, I mean, it is not meaning that adjacency matrix always have 0 and 1. Sometimes we can have multi-level adjacency matrices, like you can use dictionary, list, anything. But in this, we clearly mentioned that this adjacency matrix Mij is actually a list. No, finding maximum is not depending on, but always you end up, okay. So this is for Aditya, always same. Okay, so I think not given, that guy answer is correct. Okay, so suppose if I stand at I, then I will find a vertex J who scored maximum mark in S. Then again, if I find another vertex which is J prime with a label S, and after J prime I did not find anyone, it means this person scores maximum mark in the subject S. Yeah, your claim is correct, and there can be a, okay, so as you iterate over all, okay, that is Prabhu's answer. Okay, fine. Okay, I will show you the case where both are different. Q6 is true because we end up with the maximum mark. Q7, okay, so Q7 are always same. So suppose let I and J, I scored 95 in mathematics, J also scored 95 in mathematics, and 95 is the maximum mark. Then what is the return value of I find of M comma I comma mathematics, and find of M comma J comma maths. Assume that 95 is the maximum mark. What will you get? What is the value of these two? Yeah, we will get the same I because no one scored more than I. Yeah, in the second case, we will get J scored more than J. Okay, since I not equal to J, because note the statement that let I and J be two different students. Okay, I not equal to J. It is not that always find of MIS and MJS returns the same. They can be different. Yeah, 95 is maximum. Yeah, if there is only one maximum, then I and J are same. That is correct. Ravi, Anudup, your claim is correct if there is a unique maximum. But nowhere we mentioned that the score has a unique maximum. Okay, so let me explain it again. Okay, so the find procedure calls with parameter M, J, I and S. Okay, so I is the current vertex, and you are looking for no, don't consider the data set. I mean, nowhere we ask regarding the data set. It's you should know only the fields in the data set. It is not about data set. Yeah, I is a parameter. That parameter represents one vertex in the graph. Okay, so for this graph I am looking for J. So that is what for each J in rows of M. I try for all J, uh, all possible J, but there can be some J that do not have any edge to I. Okay, we have to discard them, and there can be some edge J, some vertex J that has edge to I, but that does not contain S. Then we have to discard them. We consider, okay, so we consider only the edge that contain from J to I that contains the subject S as label. Suppose if nowhere, if we did not find any successful J, then we return this I as in the base case. Okay, thanks Srinivasan. So the base case we missed. The base case is when if you did not find any J, that is who scored more marks than I, then you have to return I. Okay, so when will you return I? Suppose consider the situation, I scored 92. Okay, so let me draw one graph, in one simple graph, 92, 70, 95, 94, 98, and another 98. These are marks of the students. Okay, now how this graph constructed? This is the way graph can be constructed, because there will be edge from low mark, high mark to the low marks. So 95, 94, and 94 will have edge this line, and 98 will have edge to everyone. You can assume there are edges, many edges. Okay, right now you are standing at this point. This is your I. Okay, so if you execute your pseudocode, try all edge with subject name. Assume this is subject mathematics. I mean, all these have subject mathematics edge. Okay, and for 92 there is an edge from all the subjects, I mean all the people. 98, 98, 94, 95, 70. 70 will not have edge towards 92. Okay, so now I will switch from here to here. I will call again find of m comma 95 comma mathematics. Okay, so now we are in find of m comma 95 comma mathematics. Now for 95, try all possible vertices and check, is there an edge to 95? 94 do not have edge towards 95, so we cannot use this, we cannot use this, we cannot use it, but we can use one of these 98. Suppose if I find this is my j, then I will invoke find of m comma j comma, yes, here j is actually 98. Okay, so here again, once again I want to try all possible j. In this point my j become I, because now I move to the recursive call. So find a j such that j scored more than I. Is there anyone who scored more than 98? No, this guy scored 98, but both are same, there is no edge between them. Okay, so okay, so this find of mjs, now return this particular I. That means this is actually the return value of find of MIS. This means I will travel like this. So from this guy, I may come to this guy. So this is the way I traveled, and I now return 98. This means, so the find of IMIS is actually a student who scored the maximum mark in subject S. Okay, so maximum mark in subject always true. No, well, okay, why true comes here? Okay, Bimlesh. Yeah, 1 minute, I will unmute you. Bimlesh, can you raise your hand? Okay, yeah. Yeah, Bimlish, I request you to unmute.
Yeah, hi, good evening.
Yeah, hi, good evening.
Uh,
Yeah, what is
I
it? Do?
I had almost reached to the solution, but then I got confused in the recursive return of the procedure find. And now
Okay.
that you have explained, I would just like to tell you my understanding. That is the correct
Ah, okay.
understanding. See,
Okay.
the procedure find is returning recursively inside each and every call of the procedure. Now,
Yeah.
in the final call of the procedure in which
Hmm.
the for each loop doesn't
Hmm.
find any member, doesn't find any if condition to be true, then
Hmm.
it comes out of the loop in the final recursive call and it
Hmm.
returns that particular student sequence number, correct?
Yes, correct.
Which gets propagated to the first call.
Yes, correct.
So, okay, just because of this I and J, I got confused. Otherwise,
Ah,
this was
okay.
clear.
Yeah, I mean, you can assume when, okay, so this is the problem. So uh, we want to find of m comma I comma s, and we encounter a j. I mean, we find some vertex j,
Hmm.
okay, and a minute. Again we call
Yes,
find of m
basically
comma,
in the last recursive call,
yes, m comma
it
j.
is not able to find any edge. So
Yes,
that
correct.
that point of time, it basically it reaches that is the base condition. If it doesn't find any edge, that is the base condition, and then that particular student ID is getting propagated back to the first call of the procedure, and
Correct.
basically it captures that student ID. So that is why it is capturing the maximum student who got the maximum marks in that particular subject.
Correct. Yeah. So when you execute this return of MJS, you have to assume that you are calling again this procedure find with M is mapped to the first element and J is mapped to the second parameter and S is mapped to the third parameter. You are calling
Correct,
a
correct.
new, that in that map, if you assume your J become your new I.
Yes, yes, that is true. And that was the only mistake I committed.
Yeah,
But
so
in this,
many people get confusion because of this I, J. J in the current iteration it may be J, but when you call the recursive step, it become your I.
no, no, even this return of the final recursive call, I was confused in the for each loop. But when you explained this, I got it. That when this
Okay.
in the procedure return I, that will happen only when I is the highest scorer in the subject, and in that case for each loop doesn't enter at all. I mean, if condition doesn't enter at all. Otherwise, every time I is getting updated by the new value j in the for each loop.
Yes.
Okay.
Okay. So yeah, thanks.
And
So
and regarding that last condition also, please. I mean the second option, which is correct.
okay. Okay. So Vijayanandam, what does find m comma 95 comma m? So 98 is more than 95, right? So it will output one of the student number who scored 98. That is answer for Vijayanandam. Okay. Yeah. Okay, so we write that find of MIS and MJS cannot be same, since suppose if your I and J are the maximum scored students, two different students, then you will get different values, right? So then it cannot be same. No, no. In this case, you are getting okay. Kaushik. I mean, this is the answer to Kaushik. In this case, in some case you will get MIS and MJS can be same when you have the unique maximum, but it is not the always case, right? When you have multiple maximum, the case the yeah. So Ravi's answer is correct. When you have multiple maximum scores, then it there is a possibility that it can be anything. Yeah, in this case, two maximum, right? So from 95, why should I go to this 98? I can output this 98 also, right? This 98 ID is, let's say, this is ID 7 and this is ID 5. I can output ID 5 or ID 7. It need not to be same. Okay. Yeah. So then the third one, the procedure find executes infinitely. It will not execute infinitely. Can someone say when the code will execute infinitely for this code? The graph has some property, then the code will execute infinitely. Can someone find it? Oh yeah, Apul, I will explain it once. No, student 5636. That is not correct. If you even if you remove base case, it will work as it is. Maybe the written answer you will not get any written value. You will have only null value to be returned. Yeah, Janani's answer is correct if the graph is undirected. But we construct the graph with directions. So consider the directed case, and can you come up with some answer? Yeah, symmetric is undirected. Symmetricity is and undirected. I mean, both are okay. If case all are topper, no. If all are topper, then in first call itself I will return. The question is when will we have this undirected things? I mean, so when will I iterate continuously? Actually, in this setting we will not. Suppose, okay, so I will tell you, if there is a cycle, then there is a possibility for infinite execution. But cycle is not possible for this graph. Suppose consider there is a I and j, there is an edge from I to j, and there is an edge from k to j, and there is an edge from L to k. Okay, when I call I will go to j. When I have j, I will go to k. When I have k, I will go to L, and this will repeat. But this is will not occur in our graph because this max relation. Max relation means I is more than j, j is more than and j is more than I, k is more than j, and L is more than L. It means L is more than I. Then this edge will not occur. Okay, so then if you take one for one subject, if you consider the graph, it is actually acyclic graph. Yeah, for a fixed subject, this is actually acyclic graph. So you will not get infinite execution. You will always end up with the finite execution. Okay, so the option C is false, that the procedure executes infinitely. That is incorrect. Okay, so the next question, can we find a minimum mark student? Is it possible? No. Yeah, can someone unmute and tell your answer why it is no? Please raise hand, the volunteer. Okay, Srinivasan, I request you to unmute.
Yeah.
Yes.
In this case,
Yes.
the way the algorithm is written, you cannot find a minimum.
Why?
Because we are actually looking for the things from j to I, right? If you just
Correct.
change it, we can actually find the minimum.
No, that is fine, but why we cannot find in this case? You should, I mean, we are not changing the graph structure. There is an edge from.
No, not the graph. I'm saying the algorithm. So if you just change it to compare from I to j rather than ji,
Okay.
right? Then you would find the minimum. You look at the outgoing edges in a way, you will find the minimum.
Okay. So you will consider only if where j going to I, then go to I.
Yes.
Then when I to I prime, go to I prime. Will
Yes.
you find the minimum one? I think no, because I will tell you one example. 98 will go to 70. It can go to 60, 50, and 40. Okay. If there is a student 35, what is the guarantee you want to say here? I mean, I try to prove your argument. Okay.
Yeah.
Yeah,
So
what is the guarantee? If I say 45, I will end up, I will not reach 35. What is the contradiction you want to claim?
because see, because 45 actually this is a list, right? So there will be multiple incoming. Everybody will have an incoming edge to 35. That's how the matrix is constructed,
Yes,
right?
35. Okay, yes. So then 40 to 35, that should be edge. So you will end up with a minimum one.
Yes. Yeah.
Okay.
It just,
Yeah.
you just change the a couple of things, you will find the minimum. So that's how the
Yes.
recursion works, right? So you just change a
Yeah,
little bit.
correct. I mean, this is something advanced answer than what we asked. Something like how to change this find to find the minimum. But this very, yeah, this algorithm is a nice one. Thanks, Srinivasan.
Thank you.
Okay. So, but this current setup we cannot find because we can go find the maximum one. We cannot find the minimum one. Okay. Yeah. So, okay, let us go to the. Okay. So, is there any discussion regarding this question? Hmm. Okay, so the changed code is actually if you change uh, member of mij, then you will get the answer. I mean, you have to change the third line member of ji instead member of ji. You have to change member of ij. So this is, I mean, something out of curiosity. Those who are interested want to do, you can try member of mij. You will get it. So that, I mean, so the credit to Srinivasan. Okay, so we come to the last part. Last part is very trivial, I think, because if j is equal to find of MIS, then we know j scored more than I, then only you will get. Okay, because we are navigating to the maximum scored one. Okay, so with this question and supports got over. Okay, we come to the final one. Do something procedure. No, it's not greater than or equal to. Look at the construction of the graph. We check only x dot subject mark is more than y dot subject mark. Okay, please raise hand, student 5636. Yeah, please raise hand. I am unable to find you. Yeah. Yeah, I request you to unmute.
Yeah, hello, sir.
Hey, hi. Yeah. So how can I call you? I mean, student 5636.
Yeah, sir, my name is Pritodip Dev.
Okay. Yeah. Go ahead.
Can you tell me why you want me to unmute?
Huh?
Sir, you said me to unmute. Can you,
Oh,
do you
so
want
I
me
thought
to?
you request to unmute. I mean, you want to speak. You said, isn't? Oh, someone else or you?
Sir, I thought I wrote a message to you regarding this. Somebody is trying to impersonate me with my name, and like this has been going on for
Okay,
the last.
I'm sorry. I thought you request me to unmute. Sir,
Sir,
please
sir,
unmute
can
me.
you
I
please?
have. Okay. Oh, I thought you sent a message. Okay, no problem. Okay, so now, if you don't want to speak anything, then you can. I mean, uh, fine. Sorry, I misread it. Okay, so now we come to the do something. I mean, something very mathematical function. So, how many of you find this question is very hard? That last do something. Easy, hard, tricky, not hard. Yeah, it's a yeah, very tricky one, but not that much hard. Yeah, that is what we feel. Okay, Kritika, please explain this condition whether it will be true if I has got the maximum marks than all j. If j is equal to find MIS, then j scored. Yeah, your claim is correct. Suppose if I scored maximum mark, yeah, than all j, then find of MIS is I itself. It is not someone j, because I score the maximum mark, then there will be no incoming edge to I, so that will complete the climb. Okay, it was easy, but I don't know how answer for 192 is 9. It should be 1. No, it is not 1. Okay, let me write that code once. Okay, so do something. Okay, instead of writing code, let me explain for that 192 example. 192 comma 0. What is the first condition we have to check? First we have to check this is actually n and this is my x. Okay, so the first is if n equal to 0. Is this true or false? This is actually 192 is equal to 0. Actually false. Okay, yeah. So if it is false, then I will come to y case, and what is the value of y? Y is equal to do something of, can you tell me the parameters? What I have to pass for do something now? Yes, 19 comma 2. I divide the number n by 10, and I take the quotient as the first parameter and remainder as the second parameter. That is 19 comma 2. Okay, now compute this do something. Okay, now I come inside this do something. If n equal to 0, that is 19 is equal to 0. True or false? False. Nice. Okay, then what we have to call? Y is equal to do something of 1 comma 9, because now we have to divide 19 by 10 and pass both. Okay, now again execute this do something. If 1 is equal to 0, is true or false? False. Yeah. Okay, so then next I have to call y is equal to do something of, what is the first parameter? 0 comma 1. Now implement this. If 0 equal to 0, yeah, we encountered the base case, it's true. Then what I have to return? Return 1. Actually it is return x value is actually 1, so I have to return 1. So this will return y equal to 1. Which y? Do something of 1 comma 9 is actually 1. Now what is the next condition? See, now go through the code. The next is actually if x greater than y. Okay, what is the value of x? Okay, Sumista Saha. Okay, 1 by 10 means how many tens in 1? It's a natural, I mean integer division. Then you will get a remainder 1, but the quotient is 0. Okay, yeah. So x is actually 1. No, sorry, I'm sorry. X is actually 9 and y is actually 1. X greater than 9, so you have to return 9. Okay, so now this return is will reach y equal to 9. What is the current x value? 2. Okay, so if y greater than x, this is actually sorry, what is the first condition? X greater than y. Sorry. X greater than y, this is actually false, because x is equal to 2 and y is 9. So we will return y instead of x as per the code. Okay, so then you will return 9. So this 9 is returned to this point. So now again y is equal to 9. Finally, once again check, because in this place your x is at 0 and y is 9, you have to return 9. No, not x equal to 9, it's y. Check the code, we are assigning y is equal to do something. Then the do something will return the value to y. Okay, so again you have to check x, y. The maximum among these two is actually 9. So you have to return 9. So what is the final climb? For the numbers 192, 444, is it 444? Yeah, 444, 700 and 10. So we are finding the digit with the maximum value. It can be anything in that 4 because all are 4. Yes. Yeah, Shubham Jari. Correct. We are finding the maximum digit in each number. Yes. 9, 4. That's a nice number. 90, 47. If you shuffle it. Independence here. Okay. Okay, that's it from my side. If you have any question, please post it. Okay, Apple, I will repeat that question 5. Okay, what is question 5? Yeah, that will be the good idea. So, Apple, I am sorry. So, instead of going to the question 5, let us discuss shortly regarding the CT quiz 3. I mean, some idea for quiz 3, how to prepare. I'm not expert to give you more technical content, but I will give you some idea what we can do. Yeah, so for recursion, we are recording the tutorial. Yeah, so for instead of week 12, we have some extra tutorial for the early weeks. Okay, so we will release some tutorial content, and also we are planning to release this kind of recursion pseudocode with some detailed explanation that will help you. Yeah. Okay. Could you discuss question 5 in graded? Okay, I'm sorry. I do not have any graded assignment questions with me, so it's unable to discuss this question 8 of graded and other stuffs. If you want some specific discussion regarding the graded assignments or something, please write to the forum, and there we try to answer your question. Okay, so one thing regarding this quiz 3 preparation. So let me open one more sheet. Okay. Spelling mistake. Quiz 3. Okay, what we can do, you can do one thing. So try to understand when some graph, one is related to the graphs. Suppose if some graphs questions are given to you, try to draw some sample graph. Like let's say I and j are the nodes, I, j, k, and so many. And if there is an edge between I to j, or either it can be sometime undirected edges. If it is undirected edge, you can see easily that mji is equal to mij. Then whenever you assign both I and j as the same value, then it is undirected. So just try to see whether the graph is directed or undirected. So this is the first question, is it directed? Okay, the second question, is it labeled? The question is whether the matrix mij is either 0 or 1, or some list is associated with, or some integer value other than 0, 1, or some dictionary, some complicated values are associated with this one. Okay, so this you have to analyze in the second step. So you have to find what is the label associated in the edges. Okay. Then third, what is the logic for the edge I to j? When we have edge from I to j, what is the condition to add the edge? Suppose in this, I mean, in our mock session, so we have this, yeah, fifth question related to the fifth question. There is an edge from I to j if I scored more marks than j in subject I, subject S. Okay, so these kind of analysis you have to do. Once you've done all this analysis, the remaining will be easy, because once you find the knowledge of the graph, that means, okay, this is how the graph is constructed, then the remaining pre-processing of the graph is very easy once you've done this. And we are asking question when we have edge from I to j and when we will not have edge from I to j. All these things you can easily answer. Okay, and since all the questions of quiz 3 is related to, highly related to this graph theory concepts, like graphs, recursion and other stuff. Maybe recursion you need some, I mean, if there are some mathematical question can be asked, but in if you look at the application of graph, it always like constructing graph based on student data set or some data set. Okay, so okay, so there is a message from Prabhu. Just for a clarification, when a written statement is encountered, does not it terminate the procedure? No, Prabhu. I mean, this we discussed early. Whenever a written statement found, it immediately close the or terminate the execution of the procedure, of the current procedure. Okay, so let me write on example, because we have seen this already. That is a procedure find. Use different color. And we are doing something, some parameter is given, and after some step I do if some condition c1 return some value x. Okay, it means once I reach this statement, I have to kill the execution of whole flow. I will not execute this remaining things. This, the step is killed, I mean the execution is killed. This will return wherever the function which is called from. So suppose if I find of blah blah blah, then this value is now, whatever this x value will be returned to the calling procedure. Okay, so then whenever you encounter a return statement and execution found reaches that place, then it immediately kills the execution of the procedure, I mean the current procedure. You can assume in the other way. Suppose if you have find and inside you are calling another find and inside you are calling another find, and this is killed, means this current procedure only killed. You have to return this to some I mean the execution of the find. Okay, so this you can say find 2, this is find 1, and this is some find k. Find k will return to find k minus 1, then it will return to find k minus 1, and so on. It will reach find 2 and find 1. It's like yeah, sometimes something, if you want to imagine, like time travel. One person is go back and he can see the same person if you travel back the time backwards. That is actually your copy, but from the past. Again, once again, if you travel back, that person is also time traveling. Then you can see the third copy. Something like this. This is the same copy of the procedure we are executing recursively. Okay, so maybe in this, do something. If you did not kill the execution, you are right, because this actually we choose the maximum digit based on the value. But if you execute the same way in some other procedure, you will encounter the problem. I mean, you will not get the correct answer. No, I'm not giving tips. I mean, I got just deviated from the tips. So the, I mean, it's not like a tips. Okay. Okay, so yeah, can you write? That is my mail ID. Yeah, student 5636. Yeah, that's my mail ID. Vijay at onlinedegree.iitm.ac.in. Please write. Okay. Preparation guidelines. Yeah, preparation guidelines in the sense, I mean, apart from this video lecture, you should, I mean, at this level, week 7, 8, 9, you need some kind of imagination, like how this graph can be and what is the structure of the graph, all these things. You should imagine yourself, or you can draw even in the paper because pen and paper is anyway allowed in the quizzes. And apart from that, when you have this recursion, do not get confusion of the calling parameter and called parameter. Suppose if there is a parameter procedure find, there is a procedure, let's say x with parameter abc ab, and I am calling inside x, I am calling parameter with b and c. You can see that this b is now assigned to a and this c is now assigned to b. Okay, and many people getting confusion that in the execution of the second this recursive call, b is actually, the b value is given to a and c value is given to b. It not mean that this b is updated by c, and this I have seen many people are getting confusion at this point. You are calling another procedure, the procedure names, I mean the parameter name can be anything. It can be like argument 1, argument 2, something like that. When you pass the value is given to that arguments. So you should be very careful to analyze the execution of the recursive steps when you pass the parameter to the recursive steps and identify the base case, apply the base case and see what relation you are going to build in the recursive steps. So that will help you to solve. Suppose if some mathematical function is given, no need to solve all the values of the mathematical function. If you see 1 or 2 iteration, this is what happening. Okay, so yeah, okay, so if 1 or 2 iteration, this is what happening, then you can do the same thing for the other things and simply come up with some mathematical implication of it, like okay, so it is finding some sum or it is finding some multiplication, something like that. Okay, so that you can save some time and you can spend your time and energy to some hard question instead of spending too much energy for some easy question. And also this thing, and this is very natural student mindset, spending too much energy and time for a particular question that will kill your, I mean, attempt other attempts. Okay, if you find struck, then I mean, just move out of it and then try to solve something easy so that you will get confidence and come back and solve the harder one. Okay. Yeah, so please give your feedback on the feedback link. Okay, so I will save this page and then I try to share this PDF. I'm not sure. I mean, whatever material I gave to the team, they posted in the portal. Okay, so I will share this as a PDF. Anyway, it is not well written, but you can use it for some reference. Okay, yeah, please share your feedbacks, and yeah, it's not structured one. We can do it. I mean, like it's a unstructured discussion. So I'm not prepare any slide for you guys. So anyway, because I'm going to write it on the flow. Okay. Yeah. Thanks and good night to everyone. Thank you. Okay. For YouTube link, please check the portal. Yeah. Okay, guys. Thanks and all the best for the. Yeah. Okay. Host, can you close the meeting? Okay. So otherwise, I will close it.